All right, mathletes. So I'm looking at exam 2, and I'm looking at question 2 that someone asked during office hours. So I wanted to take a look at this with you. All right. So, uh, of all the registered automobiles in the city, 5% fail the admission test. 8 automobiles are selected at random to undergo an admissions test. All right. So the question is find the probability that exactly 3 of them fail the test. So remember, two things could happen. Either you pass the test or you fail the test. And so right now we're thinking of a binomial distribution, right? We have two outputs. Our trials, the number of trials is going to be 8 because we're going to test 8 of those automobiles. And we're looking at, are they failing the test or passing? So because we're focusing on them failing or counting the ones that fail, that's what we consider a success, is when one of them fail. All right. Okay. So for part A, notice they say we're saying what's the chance of exactly 3 of them failing. So because of that, what we're gonna do is we're gonna use for part 1. Let me get my highlighter here. We're gonna use the binomial PDF because it's exactly 1. We're just looking at only one probability. All right. So just a reminder on your calculator, I'm using the app here, but you're going to hit second, then vars, because you're trying to get to that distribution button so that we could pick a binomial distribution. And then you're picking the first choice, row A, which is the binomial PDF. So on your calculator, make sure you go down and find binomial PDF. All right. So then it's going to ask you some questions. So your questions are, how many trials do you have? Well, we said there's 8 trials. What's the probability of a success? So remember, the success we're looking at is the chance that it fails. So it tells us there's a 5% chance of it failing, which is 0.05. All right? And we're looking at exactly 3. So how many failed that we're looking at? Exactly 3. So that's what we put for our X value. If you're using the phone version that we went over in class, you're typing it in exactly like this. All right. But again, if you're using the app or the calculator, once you hit enter, then it punches this out and there's our probability, 0.005. All right. Simple enough. Then it's slowly going to get a little bit more challenging. So part 2, again, this is an exam review. Someone had a question over number 22 on our exam. Find the probability that fewer than 3, so X is less than 3, of them fail the test. All right. So once again, the trials haven't changed and the probability hasn't changed. All right. But this time, because we're looking at fewer than, we're going to use binomial CDF because if you recall from our lecture, binomial CDF always starts at 0 and then it keeps adding all those probabilities. So it adds a probability of 0 plus the probability of 1 plus the probability of 2. And in that case, you would stop because notice what it says. It says fewer than 3. So we do not want to include 3. So this is why I love including a number line so you know where to stop. So this is what your calculator is doing for you when you use the binomial CDF. It starts at 0 and it adds all the way up to the last number you tell it. All right. So that's a nice function. And so this is what we get, about 99% chance of that happening. All right. Part 3. Part 3. Oh, actually, part 3 I think is on the next page. Let me get to the next page. All right, so part 3, it says more than 2. So again, I love drawing this right here, more than 2. So we're looking at 3, right? The probability, and write this down, of X is greater than 2. Not equal to 2, just greater than 2. So that's why we start at 3 here, right? More than 2. So I like having this little drawing just so I know what to include. So whenever the problem says more than, right? Or you have it to the right, you're looking at the numbers greater than. That's when you're using the complement. So we're going to do the 1 minus. But when you do the 1 minus, what you're doing is you're getting rid of all the probabilities that you're not interested in. So you're getting the probabilities, you're getting rid of all these probabilities on the left-hand side, all the way up to 2, right? You don't want to. So that's why for your x value, you go all the way up to the number you're interested. So since I did want 3, it's always this number, x value, when you're doing the complement, is always the number right before it. So that's where the 2 comes in. All right. And just like in the video that hopefully you watched on the quiz. And so everything stayed the same, except now we're doing 1 minus, and then you're going to second distribution, binomial CDF, and then the only thing that changes is now you're doing the 2 right there, because that's what you're getting rid of. So if I were to draw this, or sorry, write this out, notice, if I listed all the probabilities, if I just kept going, 3, probability of 4, plus the probability of 5, plus the probability of 6, plus the probability of 7. This is an overkill, but to really help you understand, what I really want is I'm interested in all these 3, and I'm interested in all these right here. These are the ones that I want. So what you're telling your calculator when you do the 1 minus is you're saying get rid of all these right here. That's what you're doing when you do the complement, the 1 minus, okay? So just to give you some insight. And then the last part, they're asking us, would it be unusual, right? Using a cutoff of 0.05. So once you get an answer, basically you're going to compare your solution to 0.05. And if your answer is less than 0.05, then we say, yes, it is unusual. All right. For none of these to fail. So that means x is going to be 0. And we're going to use binomial PDF because we're just looking at one probability, the probability of exactly 1. All right. So our x value is 0 because you're saying, hey, none of them fail, right? So again, the number of trials stays the same, probability stays the same. Only thing that changes now is x equals 0, and you're using PDF instead of CDF because we're just looking at 1. So once you do that, this is your probability of 0.6634, which is not less than that. So it would not be unusual. So again, if this was 0.006 as an example, that's less than this. So you say it would be unusual. So whenever you're checking for normality or if things are unusual, you're comparing it to 0.05. All right, mathletes, I really hope that helps out. Talk to you soon.